Boys and girls, time for math. So today we're starting on page 495 of your book. If you need a minute, just get that out, please, and we'll get started. So number 1 on page 495, it says draw a model to show 3 times 2/5, then write the product. So it says draw an area model. When we're drawing an area model for multiplying fractions, it's pretty much just like a visual, okay? So we need to show 3 times 2/5. That means we have to have 2/5 3 times. So I'm going to draw 3 things. And I need to split them each into 5. Doesn't have to be perfect, guys. Just do your best. Okay? And then I need to shade 2/5 of each of them. Okay. So now, if we pause me if you need to draw that. I know it takes a minute. If we look at the model, we can solve the problem. What is 3 times 2/5? Let's look and see how many are shaded. 1, 2, 3, 4, 5, 6. 6 over, I never changed the denominator, 5, right? I'm going to check that mathematically. 3 times 2/5. So we got the whole number times the numerator. So 3 times 2 is 6. Our denominator never changes for now. It says 5. So my area model represents the same thing as my multiplication problem. Okay? This one, number 2. Draw an area model to show 6 times 1/5. For time's sake, I'm not going to make you draw this whole thing out, okay? Because what you would have to do is draw 1/5 6 times, right? So you'd have to draw 6 of these and shade in 1, okay? Let's just solve this one mathematically. So we're going to do 6 times 1, which is 6. And my denominator doesn't change. It's going to stay 5. So 6 times 1/5 is 6/5. That makes sense too, because if I had 1/5 6 times, I'm going to have 6/5, right? I want you to be thinking about that in your mind as you're solving these problems and make sure that it makes sense mathematically, okay? Moving on to 496. And you're welcome for not making you draw all those fifths. That would have taken a while. Okay, now we're looking at number lines here. It says fill in the blanks on the number line to show 4 times 3/5. Then write the product. So, what I'm jumping up by here is 3/5. I have to jump 4 times, okay? So first I jump to 3/5. Then you need to add another 3/5. So what's 3 plus 3? 6. Okay, so you jump up to 6/5. Now you're adding another 3 to 6. 6 plus 3 is 9, so you can see they jump to 9/5 here. Now we have to add another 3/5. 9 plus 3, 9, 10, 11, 12. 12/5. That's what they jump up to here. The way I find the answer on the number line is since I jumped up 3/5 4 times, my answer is 12/5. Okay? Next one, we need to label the number line to show 6 times 2/10. So they already jumped up the 6 times, right? 1, 2, 3, 4, 5, 6. Now we need to write in the tenths. So each of these little lines here is representing 1/10, right? So this one's going to be 2/10. 2 plus 2 is 4/10. 4 plus 2 is 6/10. 6 plus 2 is 8/10. 8 plus 2 is 10/10. 10/10 is the same thing as 1, guys. Okay? Add another 2. 10/10 plus 2/10 is 12/10. That's our answer here. So 12/10. Okay. Next. Number 5 is asking us, how are the area models and the number line models alike and different, showing fraction multiplication? So we're just going to talk about it. When we use an area model, we're able to visually see the number of parts shaded and how many times you need to multiply that, right? A number line is very similar, but instead you're jumping up that number of times, okay? Lots of times you guys are probably going to like to use the visual model instead, okay? So number 5, you can just cross out. Okay. Now for number 6, it says choose any model to show 2/4 and write the product. So let's do an area model. We like that better. So I need to show 2/4 3 times. So I'm going to have 3 things. And I need to split those things into fourths. When I do fourths, guys, I like to do this. Make a window. On each of those, I need to shade in 2 of the fourths. So I'm shading in 2/4, 2/4, 2/4. Now, let's get the answer from our model. How many fourths do we shade? 1, 2, 3, 4, 5, 6. So based on our model, the answer should be 6/4. Let's check it using multiplication. 3 times 2 is 6. Our denominator stays a 4. Aren't we so smart? We did it. Okay. 497. All right. Find 6 times 1/4 using repeated addition. Okay. So, oh, by the way, guys, on 497, there's an example up top. You can take a look at that on your own time, but I'm just going to move on to the bottom here, number 1, okay? So, when we do repeated addition, I'm going to need to put 1/4 6 times. They already drew the 6 lines for me, so I'm just going to pop my 1/4 on each one. Okay? What does that equal? Well, I know I just wrote it 6 times, and I'm only adding ones, right? So there's 6 ones here, so that means it equals 6/4. Okay? Now, the next one, we're kind of doing a little thinking about this stuff. So it says, look at the model, tell whether each expression shows 3 times 5/8. So this here is showing 3 times 5/8. I just want to solve, when I have something like this, guys, I like to just solve the problem first so I know what the right answer is supposed to be. So I'm going to solve it out. So if I have 3 times 5/8, I'm going to do 3 times 5, 5, 10, 15 is 15. And that's going to be over 8, right? So now let's take a look at our options here. Is 5 times 3/8 the same thing? The way that I can check that is I can solve it out and see if it equals that same thing. So 5 times 3 is 15, and it's over 8. 15 over 8 is the same as 15 over 8. Yes. Next one is using repeated addition here. They're adding 5/8 plus 5/8 plus 5/8. Let's solve it and check. So 5 plus 5 is 10. 10 plus another 5, 10, 11, 12, 13, 14, 15. 15 over 8, right? So yeah, that's the same too. Whoa, 24 times 1/5? I don't think so, but let's just check. So I'm going to multiply the whole number times the numerator. So 24 times 1 is 24, because anything times 1 is itself. So 24 over 5 is my denominator here. Is 24 over 5 the same thing as 15 over 8? No. It's not. Okay, how about 15 times 1/8? So let's solve it. 15 times 1 is 15. Anything times 1 is itself. Our denominator here is 8, so that equals 15/8. That's a yes. Okay? Moving on. Now, page 498, please. This is our last page. The number line below shows blank times blank. Okay, this is a good one. So first of all, we need to figure out the whole number and the fraction. To figure out the whole number, I'm going to count the number of hops. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 hops. So that means they're multiplying the fraction times 8. Now, I need to see what are they going up by each time. 3/10. Each of these hops, guys, is worth 3/10. Okay? So they're multiplying it by, I think, 3/10 here. Now, according to this number line, the answer is 24/10. So I just want to check and make sure that I have the right equation here. So I'm going to multiply my whole number times my numerator. 8 times 3 is 24. We should be starting to know those facts, guys. If you're really doing your reflex, you should have those 3 tables down. 8 times 3 is 24, okay? So we got 24 over, my denominator is 10. Oh, cool, that matches up, right? So I know I got the right equation. Next, label the number line below and use it to show 3 times 3/4. Okay, so they already did this for me that each of these is 1/4. I know that because this is 1/4, 2/4, 3/4, 4/4 is the same thing as 1, right? I know I'm going to need to hop up 3 times, and those hops are going to need 3/4. So I'm going to label my fourths first, okay? So I'm going to have 1/4, 2/4, 3/4. 1 is the same thing as 4/4, 5/4, 6/4, 7/4. 2 is the same thing as 8/4, 9/4, 10/4, 11/4, and 3 is the same thing as 12/4. The reason for that is, guys, because 4 goes into 12 3 times. 4 goes into 8 2 times. Okay? 4 goes into 4 1 time. Just want you to know that. Now, I'm ready to hop. I need to hop up 3 times, and each one has to have 3/4. So the first one's easy because I'm just going to go from 0 to 3/4. Now I need to make sure I'm adding 3 more fourths. So what's 3 plus 3? 6. So I'm going to need to go up to 6/4. What's 6 plus 3? 9. Going up to 9/4. Okay? So according to my number line, my answer is 9/4. All right. Draw a model to show 3 times 4/5. So that means I need 3 things that are each split into fifths. Okay? I need to split these into 5. Okay. And now each of these has to have 4 of the fifths shaded. Pause me if you need to catch up. Now I'm going to solve my problem. I'm going to see how many fifths do I have shaded in all. Well, I have 4 plus 4 is 8. And then 8 plus another 4, 8, 9, 10, 11, 12. 12 over 5. All right. Last few problems here, 2 more. I'm on number 6. Okay, I like this problem because it's kind of like a puzzle. It says, look at the model you drew in problem 5. Use 2, 3, 4, 5, and 6 to write 2 multiplication problems with the same product as 3 times 4/5. So, our answer for 3 times 4/5 is 12/5, right? 3 times 4/5 is 12/5. I'm just going to write that down so I don't forget it. Okay. So, I need to figure out what whole number I can multiply by a numerator to get this, okay? First off, I know my denominator does not change. So my denominator is going to stay 5 in both of these. And so in order to find some different combinations, here what we did is multiply 3 times 4, which gave us 12. What other 2 numbers can we multiply to get 12? How about 2 times 6? Isn't that 12? So this, if I did 2 times 6, it would be 12 over 5. So that works. Now I need another combination here. How about I put the 4 here? I start with the whole number 4. 4 times what is 12? 4, 8, 12. 4 times 3 is 12. Okay? That's another combo. These both equal 12/5. That's the point of this. Okay. Number 7, we're just going to talk about it. Lisa says that 3 times 1/6 and 3/6 plus 3/6 plus 3/6 have the same value. Is she correct? So, when we were to multiply 3 times 1/6, we would do 3 times 1, which is 3. If you just want to listen, you don't have to write this down. And then it's going to be over 6, right? So the answer for 3 times 1/6 is 3/6. What's the answer for this? Let's add the numerators. 3 plus 3 is 6, plus another 3 is 9 over 6. So no, that's not going to be the same, right? Because in this case, your repeated addition, you're adding 3/6 3 times. For multiplication, you're just multiplying your 1/6 times 3, right? That's the difference there. All right, guys, don't forget about that reflex. Please make sure you're doing that, and I'll talk to you soon.